How we doing, guys? This video is just a quick one to show you where the simple pendulum formula comes from. Those who are doing physics have made it before. It is to say that the period of a simple pendulum is proportional to the square root of the length of the string. So a simple pendulum is just a string with a weight at the end of it. And it's one where we restrict the size of this angle to being relatively small. Typically we say less than 5 degrees. If you move it, okay, you can see it's going to move up in a circle. The angle that you subtend in radians is arc length over radius of the circle you're moving in. Okay, so that's just our definition of radians. So our arc length here we're going to call x, and our length of the, our radius is going to be the length of the string. We're also going to use something called a small angle approximation. So the small angle approximation is described here on page 233 in the book. For a small angle, if you measure it in radians and take the sine of that angle in radians, they're approximately the same. Okay, now once you get up past 5 degrees, you see, a slightly more significant change. But even there, when theta is 10 degrees, the difference between theta and sine theta is less than 0.001. So in general, we're going to say that theta equals sine theta. Okay, so the angle, or the sine of the angle, theta, as long as theta is small, is about the same as the angle itself as measured in radians, which can be given by x over L. So if we examine our simple pendulum, once we move it a little bit beyond its equilibrium point, which is when it's hanging straight, you've got the weight is the only force acting downwards, and that is going to act in these two directions here, okay, against the string, against the tension in the string, and perpendicular to it. And that angle theta is going to crop up again down here. Okay, those two lines are parallel, so these are corresponding angles and parallel lines, and that means this bit here is the opposite side, so that's going to be mg sine theta is the component that's acting in the same direction as x. So that's our force. Okay, we can say the force acting here in the x direction. Okay, so let's say that direction here. Remember, for very small angles, that's essentially a left-right force. Is going to be mg sine theta. Okay, which means our acceleration is going to be g sine theta. The force is also, if x is positive, is moving to the right, then that force is negative, moving to the left. So it's minus g sine theta, and using our small angle approximation, we say sine theta is about the same as the angle, and which we're going to measure as x over the length. We're going to get gx over L, minus gx over L. Okay, so A is minus g over L x. There's our simple harmonic motion formula coming up, with omega squared is g over L. So the period of a simple pendulum, okay, omega is going to be root g over L. The period of a simple pendulum is going to be given by t equals 2 pi over omega, okay, which is over root g over L, which is the same as 2 pi multiplied by root L over g. So here's our simple pendulum formula. Okay, that's our periodic time. That's in the log tables, and we'll be using it in the next exercise. We meet it on the physics course as well. One of the things that's really interesting about this formula is that if you know the length of your pendulum, which is an easy thing to measure with a ruler, the period is an easy thing to measure with a watch, okay, you can work out the acceleration due to gravity pretty accurately. So by squaring both sides here, I'm going to get 4 pi squared L over g equals t. Okay, I'm going to divide through by t, multiply up by g. Well, let's do that in 2 steps. 4 pi squared L is t. G, and dividing through 4 pi squared L over t. Oh, excuse me, I squared both sides, so I should have squared that over t squared. Equals g. Okay, so you can work out the acceleration due to gravity at any point on the Earth with just a pendulum, which is pretty incredible. It's very basic technology. If you can measure the length of the string, in meters, and you can measure the time it takes for it to go across and back again in seconds. And typically what you'll do is measure 20 periods and divide by 20. You can get a measurement for G, and you can do this at home. If you have a string and a weight, I'd very much encourage you to do it. Pick an easy length, 1 meter or something like that, and keep your angle small, and you should get a pretty close value to 9.8 meters per second for G. So we'll be using that in the next section. Okay, so I'll see you then.